Day 43 here. Today we're doing kind of a difficult skill, a skill that sketching graphs. And it's a skill you won't necessarily have to sketch your own graph, but oftentimes the multiple choice, like we saw today in class, a lot of the multiple choice questions say, which of the following could be the graph of f prime, right? And they'll have 4 graphs already sketched for you, and you have to choose the right one. Well, being able to sketch one ourselves can really be helpful, not only in terms of getting the answers right on these, but conceptually understanding what's going on. Okay? Now, it's helpful to be able to sketch an f prime graph based on an f graph, or the reverse, sketch an f graph based on an f prime graph. Okay? So it's kind of the same thing, but going in reverse, it takes kind of a lot of brain power to figure this out. In terms of key takeaways from sketching a graph, to do this right, I really focus on critical points. Going f to f prime, or vice versa, f prime to f, it's going to be really important to identify critical points, and we'll use those as kind of our anchors to get an idea of what our other graph is going to look like. Okay? So I focus on critical points when possible. If I'm given an f double prime graph, I can't do that. Okay? So I focus on critical points, and sometimes I need to get more detailed, like focal max, min, things like that. So I like to focus on critical points. So it's very important to know our critical point definition. The critical point is when f prime equals 0 or f prime undefined. Secondly, after I focus on critical points, I like to focus on increasing, decreasing. I like to focus on whether f is going to be increasing or decreasing. Well, if you have a graph of f, it's really easy to tell when it's increasing or decreasing. Is it going up or going down as we move left to right? But if we have an f prime graph, we're going to determine that by is f prime greater than 0 or less than 0. Okay. Sometimes you can narrow it down, or you can figure out which one it's going to be just based on those two things, but sometimes you can't. As a third thing that I check sometimes, I focus on concavity. So sometimes we can tell things based on concavity as well. Okay, so I'm going to give you a couple examples here. I'm going to give you a graph, and we're going to try and sketch a different graph. Okay, so let's take a look at an example. So I'm going to sketch a graph here that I want you to follow. Okay, so I'm going to call this graph, this is the graph of y equals f of x. Okay, so I'll pause the video for a second and sketch that graph the best you can into your notebooks. Our task is going to be sketch the graph of f prime. Okay, so we're back. My goal here is I want to make a graph of f prime of x. Okay, now I really want you to focus on the words sketch here. This does not have to be perfect, We just want to get an idea of what f prime looks like. It's just a sketch. It's not a create a perfect graph scenario. Okay, so my number one strategy is I want to focus on critical points of f. Okay, so what I'm going to do is I'm going to look at this graph and I'm going to determine what are the x values of my critical points. Now it's really important to know how to do that, right? Let's assume that these are all going by 1. So this is, oops. This is 1 and this is 1. Okay. Everything is going by, these squares are divisions of 1. So what I want to do here is I want to figure out what are the critical points of f that'll help me in my sketch of f prime. Now again, here's where we need to be careful. We find critical points differently whether we're looking at a graph of f or a graph of f prime. So again, we go back to our definition. Critical point of f is when f prime equals 0 or f prime undefined. Okay. So am I looking for the zeros here, or am I looking for horizontal tangents, right? That's the question that we need to answer accurately in order to do this. Again, this graph right here is a graph of f. I am not looking for the zeros of this graph. I don't really care about the zeros of this graph right now. I'm trying to determine where f prime is 0 based on an f graph. Well, f prime is the derivative of f, so I'm looking for where do I have slopes of tangent lines that are going to be zeros. Well, I can see that I have one right here. I have one right here. And I have one right here. In all three of those places, f prime is going to be 0. Because the derivative of f, the slope of the tangent line to f there, will be horizontal. Horizontal slopes have a value of 0. Those 3 points are going to be very important in my sketch of f prime. They are going to need to be the zeros on my f prime graph. So this is going from f to f prime. So right away I know on my graph of f prime, I should have a 0 at negative 1, 2, 3, and at positive 1, and at positive 3. So right away I want to map my critical points from f to f prime. Critical points of f are horizontal tangents of f. So I'm going to go ahead and plot my zeros at negative 1, 2, 3, at positive 1, and at positive 3. I know that those are 3 points that I can identify on here. Okay. Now, we can figure out the rest of this sketch of this graph. Again, it doesn't need to be perfect, but we want to get the general idea of what it would look like so that on a multiple choice question, we could answer this thing correctly. Okay, so let's take a look at our first critical point at x equals negative 3, right here. And I want to look to the left of negative 3. When I look left of negative 3, I'm wondering, is my graph of f increasing or decreasing? Well, this stretch of the graph over here is most definitely an increasing stretch of the graph. So what does that tell me about my f prime then? Well, in all of those cases, f prime must be positive. So in my f prime graph that I'm sketching myself, to the left of negative 3, my f prime graph better be above the x-axis. So I can right away go ahead, and I know that over here, left of negative 3, my function must be increasing, so f prime must be positive. Okay? What about after negative 3? Well, from negative 3 all the way to 1, what is f doing in terms of increasing and decreasing? Well, on this stretch, again, I'm looking at the F graph here. Very easy to get mixed up on what you're looking at. We're looking at the F graph between -3 and +1. That whole time, F is decreasing. Therefore, on my F prime graph, F prime should be negative from -3 all the way to +1. So I know that whatever this graph is doing, I don't know exactly what it's doing, but it needs to be in the negative realm all the way until I get to +1. Okay. Next. Between my next two critical points of 1 and 3, I see that F is increasing for that whole time. So F prime needs to be a positive number for everything between 1 and 3. So on my graph between 1 and 3, I want to connect them, but stay up above the x-axis. Now, after I pass 3, what happens here? Well, once I pass 3, F is now decreasing, it looks like forever. So my F prime then should be negative for the rest of the time, and it should look something like this. Now, after you've sketched your graph based on critical points and increasing, decreasing, we can go back, and do our tests that we know to be true about our F prime graph, right? When we look at this F prime graph, I should know what kind of critical point this is, right? How does F prime change at -3, at x equals -3? Well, F prime went plus to minus, right? So therefore, this should be a local max. This should also be a local max, because in both cases, F prime switched from plus to minus. But at x equals 1 here, this should be a local min. Now when I go back and look at my F graph, I should see a local max at -3 and +3, and I should see a local min at x equals 1. And I do see that these are both local maxes. And 1 is a local min. Okay. Also think about concavity here. Right? If it helps, just to think about it. The graph appears to start concave down. Looks like it's concave down. I'll use a different color. Concave down from here to here about. Then concave up from here to here. And then it returns to concave down at the end. So let's see if that matches with F prime, what we know about F prime. So that means that F prime should be decreasing from -infinity all the way out to around -1. And F prime is decreasing on my sketch. F prime is decreasing from -infinity down to about -1. Then I switch, right? Then from about -1 to about, I don't know, maybe -2 or +2, F prime should be increasing, which it is. And then F prime decreases again at the end. And all things that we can think about while we're doing these. Let's try another one. Okay, once again, I'm going to give you that this graph is y equals f of x. Okay, I'm going to give you that these are going by ones. what we need to do is sketch a graph of f prime. So go ahead and pause the video, put that sketch into your notes, and let's figure this thing out. Right away, we know that there's going to be some interesting stuff going on because of that terrace point. Okay, welcome back. We're going to go ahead and try and sketch a graph of f prime. So let's sketch a graph of y equals f prime of x. We're going to go by the same scale, 1 and 1. Okay, the first thing I want to do is I want to identify the critical points of f. Okay, critical points of f are when f prime is 0 or f prime is undefined. Once again, just like the last example, I'm working with a graph of f of x here. So critical points are going to be at horizontal tangents. Okay? So I want to find all the horizontal tangents. Well, I see horizontal tangents here at maybe negative 1.7 or something. I see a horizontal tangent here, and let's call it x equals 1. But there's another one. Over here is a horizontal tangent at, what is that? Here's -2, -3, -4. Somewhere between -4 and -5. Okay? Once again, since those are all 3 horizontal tangents, those are where f prime equals 0. Those should be my zeros in my sketch of f prime. So the first thing I want to do is plot all my zeros. That helps out a lot. So I'm going to plot a 0 between -4 and -5, a little bit closer to -5. Okay, 1, 2, 3, 4. So I'll plot my 0 maybe right about here. I should have another 0, right? Another place where f prime equals 0 was at -1.8-ish. I'm going to call it right here. And these are rough sketches. Don't worry too much about it. And then I should have another 0 at 1. So those are my 3 zeros on my f prime graph, because those are the 3 places where f had a slope of 0. Okay, now let's talk about increasing, decreasing. I'll go to my first critical point at like between -4 and -5. On this stretch of the graph over here, I want to know, is f increasing or decreasing? Well, f, as we move left to right, is most definitely increasing as we approach that -4.8 from the left side. Since all my slopes over here would be positive, right? All my tangent line slopes would be positive, my f prime graph should be above the x-axis to the left of that number. So I know over here, on this side, it should be positive. Again, I don't know exactly how it works, but I'm just sketching. I know to the left of that point, f prime needs to be positive. Okay? And let's take a look now to the right of that -4.8. When we get to the right side of the graph, notice my graph is still increasing. My graph still increases all the way until I get to -1.8 or whatever it is. Okay? So that whole other stretch from -4.8 to -1.8, f prime should be positive because f is increasing that whole time. So how should I connect this point and this point? Well, they should always be above the x-axis. It should look like something like that. Okay. Weird, right? Now, when we analyze our f prime graph, when I look at that negative 4.8, right, that's a critical point, I can tell. But it should be a critical point that's neither a max nor a min, because f prime didn't switch signs. Just like on our f graph, that was a critical point, but it wasn't a local min or a local max. Okay, weird, interesting. Now let's take a look at the next stretch between negative 1.8 and positive 1. Between negative 1.8 and positive 1, I can tell that my f graph is going down, so f is decreasing. What does that mean about f prime? Well, f prime must be less than 0. So to connect those two critical points on my f prime graph, I have to go below the x-axis to show that f prime is negative, to show that f is decreasing. So these two should connect below the graph like that. Now, from 1 out to infinity, my graph appears to be continually increasing. So f prime should be continually positive. And it should look something like this. Again, it's a rough sketch. But analyzing my f prime graph, this should be a neither point. This, analyzing my f prime graph, should be a local max, because f prime switches from plus to minus. This should be a local min, because f prime switches from minus to plus. Let's go back and analyze our f graph to make sure that's true. I do have a neither point at negative 4.8. I do have a max at negative 1.8, and I do have a min at positive 1. So it matches. All right, now let's try the fun one. I'm now going to give you a graph of y equals f prime of x. So here comes f prime of x. Here is f prime of x. Once again, I want to sketch now, instead of sketching f prime, now we're going to sketch f. So our goal is to sketch f. So go ahead and pause the video, sketch that graph, and then come back to see how we can do this. Okay, we're back. The first thing that we need to know about this is I'm not going to know at all about my zeros of f. I don't know where they're going to be, and that's okay. Okay, it's one of the mysteries of integration. When we integrate things, right, when we go backwards from f prime to f, we don't know how this graph shifts up and down. Okay, and that's okay. So we're not going to worry about labeling our zeros like we were the last time. What we're going to worry about is our critical points and making sure that they look like the type of critical points that should be on f. Okay. So again, I always start with the critical points. Now I'm finding my critical points differently now than I did in the first two examples because I'm looking at an f prime graph. My critical points are now, again, it's still when f prime equals 0, right? But I'm not looking at the slopes of the tangent line to this graph. I'm looking at the zeros of this graph. So I'm going to have critical points right here, here, and here. So those are my critical points at negative 1, 2, 3, negative 4, at 0, and at 1, 2, 3, 4, 5. So at those 3 points, I have something very interesting going on in my f of x graph. Okay? What kind of critical points are these? Well, let's take a look at this first one. Okay, how does f prime change at negative 4? Well, f prime switches from a negative value to a positive value. Anytime f prime switches from negative to positive, I know that this should be a local min. How about right here? This should be a local max. Right? These are of f, right? Of f, of f. That should be a local max of f because f prime switched from plus to minus. Once again, I have another local min over here. Okay. So when I sketch my f graph needs to have a local min at -4, a local max at 0, and a local min at 5. Now, I know nothing about the zeros of my f graph, and that's okay. Okay, that's just fine. The other thing we might want to consider here are inflection points, right? I'm going to have an inflection point at -2, and I'm going to have an inflection point at 3. Those are going to be inflection points. I'm not going to worry about them too much on my first draft of my sketch here, but I'm going to consider them later on. So here's what we're doing. We're going to sketch a graph of f. The next thing I want to do is consider increasing and decreasing. Okay? I have a local min at -4, I have a local max at 0, and I have a local min at 5. So the left of 4, what is f doing? Increasing or decreasing? Now be careful, this graph looks like it's increasing, right? But we don't determine increasing or decreasing on f prime by is it going up or is it going down. In this region, f prime is less than 0. That means f must be decreasing here. So, on my sketch, here's -4. I want my f graph to be decreasing from -infinity until I get to -4. Now I could start this up here, I could start it down here, it doesn't really matter. I'm going to start it up top just to have a little bit more room to graph. So my function f should be decreasing until I get to -4. And I know I should have a local min at -4. So there we have it. Between -4 and 0, 0 is a max for me. Between -4 and 0, I look at my f prime here and I see, oh, my f prime is greater than 0 for that whole stretch. That means that f must be increasing for this stretch. So I'm going to increase my f until I hit 0. So I'm just going to make f increase until I hit 0, knowing that 0 is going to be a local max. Now, from that local max of 0 to my local min of 5, this whole time, my f prime graph is below the x-axis, so it's negative. So that means f must decrease. F needs to be decreasing from 0 all the way to 5. So 1, 2, 3, 4, 5. Here's 5. I know that my f graph needs to be decreasing that entire time until I get to -5. Now, if your sketch didn't cross the x-axis, that's fine. If your sketch did cross the x-axis, that's fine. Right? It's just a sketch. It doesn't have to be perfect. And I should have a local min on my f graph at x equals 5. Then lastly, I want to look at what's happening after 5. I should have a min at 5. Out here, f prime is greater than 0. It's above the x-axis. So f must be increasing out here. And that goes for infinity. So I should have my graph increasing for infinity. So there's a rough sketch of what f of x might look like. Your sketch might look just like mine. It might look very different than mine. If I was going to grade this when we're looking at this thing on Wednesday, here's what I'm looking for. Do you really have two mins at -4 and +5? And do you have a max at 0? You have to have those in your graph. They have to be there. Okay? Is your graph increasing and decreasing on the correct intervals? You have to have that. Okay? But you could have a graph that looks like this. That works too. Yay. Yay. Okay? But I need to see mins at -4 and 5, and I need to see maxes at 0. Because this graph could be shifted anywhere up and down the x-axis, or up and down the y-axis. Okay, so that's it for today. Food for thought. This can be a little bit challenging, but it should help us with our definitions. It should help us with our concept of what's going on. I'll see you guys on Wednesday. Take care. 2 chains.